So here's an example. Suppose that we are operating an orchard. We're running an apple orchard, and it costs us $22 to rent the orchard for a day. You can think of, in real life, we don't ordinarily rent orchards, although there are some people rent agricultural acreage to farm. But think of this as the opportunity cost associated with owning the land. And suppose that the opportunity cost of owning the land is equal to $22 a day, and suppose that I can hire workers at a cost of $10 each. If we look at the table then, we can see that if we hire 0 workers, we can pick 0 bushels of apples, but it still costs us $22. Our fixed cost is $22, and our variable cost is 0, and our total cost then is $22. If we hired, say, 4 workers, if you look at the line in the table associated with 4 workers, those 4 workers can combine to produce 104 bushels of apples. The fixed cost is still $22. The variable cost is 4 times $10, 4 workers times $10 each, is $40. And the total cost then is $62. And you can look at the way that the production, the number of apples in the second column, translates into variable cost, fixed cost, and total cost in the 3 columns to the right. So then the total cost increases from $32 to pick 32 apples, or 132 apples can be picked for $82. Now we can think about the marginal cost of picking apples as well. To calculate marginal cost, what we want to do is compare the change in cost, the change in total cost, with the change in output, the change in quantity. So when we hire the first worker, we go from picking 0 bushels to 32 bushels. In the column at the far right, we see that our costs have gone up by $10, and our quantity of apples has gone up by 32 bushels. So this means that our marginal cost is $0.31, or 31 cents per bushel. If we hired a second worker, our cost increases from $32 to $42. We hire another worker, so our additional cost is $10. We get 28 extra apples, so this is, or 28 extra bushels of apples, so this is an increase of 36 cents per bushel. The marginal cost of a bushel of apple then is 36 cents. We can do this all the way down the line. Worker number 6 costs us $10, increases our output from 120 to 132, take the $10 increase in cost, divide by the 12 additional apples, and we see that this is 83 cents is the marginal cost associated with the apples picked by worker number 6. Calculating average costs is simple. We just straightforward divide the total cost divided by the number of apples will give us the average total cost. Or we can divide the fixed cost by the number of apples we pick to obtain average fixed costs. And we can divide the variable cost by the number of apples we pick to obtain the average variable cost. So if we look again at what happens with worker number 4, if we hire 4 workers, we pick 104 bushels. This is $22 in fixed cost divided by 104 bushels is, if you look at the average fixed cost column, this is associated with 21 cents per apple in fixed costs. The variable costs, we've got $40 in variable costs divided by 104 apples, is about 38 cents per bushel in variable costs. Add those two together, and with a little bit of rounding error, we get 60 cents on average per bushel in average total cost. So we can represent each of these things graphically, and what we see here is that if we examine a graph of total costs, total variable costs, and total fixed costs, we get a pattern that looks like so. They're upward sloping. This should not be a surprise. The more you make, the more it costs. So if we want to increase our output, it's going to cost us more. So total cost rises as we increase our output. Fixed cost does not, however. Fixed cost is just a horizontal line. It does not depend on output. The graph here, which just replicates the numbers in the table we saw on the preceding slide, shows a horizontal line for total fixed costs at a level of $22. The variable cost, now note that variable cost starts at the intercept, at $0 and 0 apples, while total fixed cost starts at $22 on the horizontal, or I'm sorry, starts at $22 on the vertical axis and goes up, but that the shape of the total variable cost and total fixed costs are identical, just the total cost line is $22 higher than the total variable cost line. Marginal cost can be seen by looking at the slope of the total cost curve or the total variable cost curve, which are exactly the same. The slope of the total cost curve represents marginal cost. The increase in cost is the rise in the slope, divided by the increase in output, which is the run in the slope. It tells us that the slope of the total cost curve represents marginal cost. And notice that marginal cost is rising, that the total cost line is getting steeper. And this is because of the law of diminishing marginal product that we thought about when we thought about production functions. As each worker becomes less productive at the margin than the one before us, it must be getting a little bit more expensive to squeeze additional output out of each additional worker. If we look at a graph of our average cost curves and our marginal cost curves, we can see some interesting patterns here as well. The first one we'll start with is think about average fixed cost. And note that average fixed cost is always falling. The numerator is fixed cost, and that doesn't depend on output. And the denominator is output. The denominator is quantity. So the more we produce, the more we can spread our fixed costs over. Average variable cost rises because of our diminishing marginal product, and marginal cost rises for the same reason. And what we wind up with then is that average total cost is U-shaped. Average fixed cost is more important and falling early on. Average variable cost becomes more important later because average fixed cost gets to be a very small number the more and more we produce. So what we wind up with is average total cost curves that take on a U-shape. The other thing that's important to notice is that the marginal cost curve cuts through the very bottom of the U. Right? When the marginal cost is below the average, it must be pulling the average down. But as soon as the marginal cost exceeds the average cost, it starts to pull the average up. The bottom of this U turns out to be a very important point and a very important thing that we're going to use in a lot of our lectures going forward. These diagrams represent what I'll call typical U-shaped average cost curves, and this turns out to be a useful way to describe lots of production functions and lots of production processes in the short run. And the logic of this is simple. As we produce more, we can spread our fixed costs over more units. But as we hire more workers, as we try to increase Q in the short run without adding capital, it gets harder and harder and harder to squeeze more output from the next one. We have to pay more to get the last bushel of apples than we did to get the first bushel of apples.